that Vlad listed comes with their own challenges, so I wanted to cover the sorry, definitely everyone knows that what are the differences between Web 2 development, that's how we call the traditional backend development, and the Web 3 development, the smart contract development with Solidity. The first difference is that, well, code readability is still more important than like some raw performance. Performance is much more enshrined than in Web 2. So for instance, in Web 2 there is a thing called Node.Js, and the only reason why it exists is because people who write code in JavaScript, they expect that, well, okay, even if it runs 2 times slower than some C++ code, never mind, I can just like spawn multiple instances of the server, and since the horizontal scaling is cheap, people will be fine with that. In Solidity, there is no horizontal scaling. All the actions on most popular blockchains are not parallel at all, they're sequential. And the other thing is that if your code is 2 times slower, that is, takes 2 times more operations, your users will pay 2 times more for using it. And we're not talking cents or fractions of cents, we're talking dollars. So for users, it might be like $50 or $100. And that's why we might spend quite some time on like tweaking the code to make it as efficient as possible. But maintainability of code is still very important, and it's still more important than some raw performance. Also, the security becomes much more crucial. In Web 2, when you build a server, you can kind of guard it from the outside world. The whole point of Web 3 is that it's transparent and it's permissionless, that is, anybody can access it. And that means that if there is a little bug in your code, there are billions of people on this earth, on the earth that will come and exploit it. That's why security becomes really crucial, and we'll see examples of it later on. Also, the identities of the users are not managed by the server. Like currently, user has some login and password, and he has them on Google or whatever service like Facebook or Twitter. But in crypto, users hold their own keys. They are the owners of their wallets, they are the owners of their address. And also, one of the biggest advantages of Web3 is censorship-resistant. It is possible to create some kind of censorship there, but it will be expensive and nobody does that in practice. Okay, so here's an example of tweaking to make the code faster. If you see there is a comment that all these like 10 lines or maybe 15 lines of code, they're all just equal to 1 liner, which we still avoided just to make cost cheaper to user. And this is how a lot of parts of the Solidity contract may look like. And about security, in the recent years, billions of dollars were stolen in various crypto hacks. And that's why a lot of companies, they heavily rely on audits. And that's why I said that code readability is still more important than performance, because your code needs to be auditable. Outside, developers need to be able to read it so that they can audit that there are no bugs in there. Also, there is like an interesting difference, is that bug bounties in the Web 2 world, like in normal traditional world, are relatively low. So we searched the web to find the bug bounties of Google, Twitter, Facebook, Amazon, like the most like the biggest companies. And $100K might sound like a lot, but compared to crypto bug bounties, this is pathetic. Even zkSync, our company, for critical bugs, it provides a bug bounty of more than $2 million. And that's not the biggest bug bounty out there. The biggest ones are like $10 million. Also, users on the identity, as I mentioned, you can see how beautiful login form might look like in the normal everyday website. You can see that Google, Twitter, GitHub, etc., they all hold like login and password for the user. The identity is stored on their servers. But in case of Web3, users can connect with their MetaMask wallet, and MetaMask wallet does not own their private keys. So it comes with some drawbacks as well. For instance, if your private key is lost, your wallet is lost as well. There is no recovery of it. But yeah, I think that maybe in the future there will be a mix of it, but that's how raw Web3 looks like. About censorship resistance, I want to raise the the difference between Web 2 and Web 3. So in Web 2, here's an example, like a Twitter banned Donald Trump. You might like him or dislike him, but in any case, this is an example of censorship where Twitter can just come and say, okay, guy, you will never ever publish on this website again. On Web 3, people can try to do this. So for instance, here Uniswap, he banned 10 countries without an explanation, but the difference from Twitter ban is that on Twitter, Donald Trump was banned from everywhere. There's simply no way he would ever write anything on Twitter. In case of Uniswap, only front end could be blocked or could be censored. The backend part, the smart contract part, it's still permissionless. So in a few hours after this ban came, there were some guys who released multiple different copies or versions of Uniswap frontend accessing the same smart contract backend, and that's it. The guys that were blocked in these countries can now access the same servers again. It is the same as if for Twitter, they created another client that would allow Donald Trump or anybody who has been blocked there to publish data. Also, a small bit of motivation, at least as of now, Solidity developer salaries are quite higher than average. Obviously, this is because the industry is booming. There are not so much developers there. But if you're thinking about an interesting career where you will build new projects, or if you really like solving puzzles, especially finding security issues, etc., this might be the job for you.
All right, and also topic how to become a Solidity developer. Start to describe a lot about what exactly it is, but how to become. So firstly, when I started working with Solidity, I just read the documentation. I thought, okay, I'm hero of the Solidity and can do anything. But actually, it doesn't work like that, especially for the security, because there are a lot of best practices that you should follow, and also there are a lot of tricks on the implementation of the virtual machine that's used for Solidity. And there are also some tricks for the Solidity itself. And because Solidity was written in such a way that you should actually write the code and think about the cost of the executions. Because of that, sometimes it's tricky to understand what can go wrong. And that's why I think that's a better way to actually become a Solidity developer. It's write code from open source projects, and also what's actually good is read. It is also really good to read some bug bounty stuff that's related to security, and you can know what actually can go wrong. So I really appreciate it when people write a bit of explanation what was wrong on their code, and you can use it for your code. And also, it's really good to participate in different hackathons, competition, whatever you can use. And then you can switch to Solidity development. There's examples of some courses. One of them is Crypto Zombies. It's a simple course when you want to start working with Solidity, and there is another one, Encode Solidity Bootcamp. Actually, I was participating in it, and there is two different sections. You can participate in usual one and for the hero of Solidity, something like that. So there are two different levels, and you can choose whatever you want. And about the open source code, there's Uniswap version 2. It's standard protocol that you should read before using and write contracts. And Open Zeppelin library that also used commonly in the industry. So it would be quite good to understand how they work and use it in your contract to not introduce new bugs and write new codes to all. For the hackathon and competition, there is one famous is global, and also underhanded Solidity. It was like tricky contest where participants wants to like write the contracts and hide a bug inside of it, but code should be not really big. And sometimes there's like brilliant of describing the bugs and also very, very useful. Yeah, and actually it requires a bit of luck to start working with Solidity. Pretty.
Yeah, I just want to mention like why luck is required. If you look at the job boards, they're typically like only senior positions, and if you like don't want to become a junior and then like go to senior, it will, yeah, it will likely mean that you will need to like switch inside your own company, and that will be hard because there isn't like a lot of Solidity code. Actually, because contracts have size limit, they can be omitted, but generally it's the code base is smaller than a typical backend code base. Also, Solidity code base doesn't change too often because it's usually immutable, and so there is kind of like, I would say there isn't like a huge demand for Solidity devs on any new project unless it's big enough. Agree?
Yeah, exactly. So I think we have time and we can see one example of the contract that we can in Solidity. Do you see that? Okay. So it's simple contract. Actually, it's a contract of token, and just to describe how Solidity works. So the line is pragma. It's describing for the compiler which version of Solidity we want to use. Then there is a keyword for the contract. It's quite similar to the keyword class in object-oriented languages like Java or C++, and the name of the class. Then there is a section of variables that related to that contract, and there is some usual common used types like string and a bit strange as address. So for the case of address, it's just identity in the blockchain, like your Gmail account or something like that, but in blockchain. Also some types um, for the integer and some kind of mapping. It looks like a hash map of address to integer, but actually it works like key value storage. Yeah, and there is also a function that was called while initialization finished. It's constructor. In this constructor function, we provide the variables that we want to store as a permanent storage and use it later. For the case in our token, there is name and symbol. We make it. We use keyword public to make this variable be accessible from everywhere. Yeah, and save as owner of contract to be sender to address of whom who uses contract, who create a call, and just simple function to mint tokens that use address and integer for to an amount. There is one assert for getting known that address who calls the contract is owner. If this statement is not true, the whole call will be reverted and no changes will be stored on the blockchain. And then we update the balance of address and increase the total coins that we have. And simple function for the transfer, similar that we have previously, but there is assert for the balances. It should be greater than amount that you want to transfer. Decrease amount of sender and increase for receiver. And now we have simple cryptocurrency in the Solidity. Right. And one function just to have getters from the blockchain. As I said, that everything that you stored on the contract is public, and you can access this data. However, not everything is easy to access. So you can provide a user-friendly function to get data, or you can push your user to get the data from the blockchain by themselves. And in case of the owner, we don't have a function for the getters this value, but for the total coins, we provide such value. Right. Think questions?
When do you use this view? Doesn't that last when you have external view and another one?
Yeah.
And
So
this one when it returns something?
no, but okay. So view we use for the getter function.
Oh.
So if it does not change the blockchain value, so permanent source, so we can use this view file.
Who wants to become a blockchain developer? Will you join the courses that are provided in the presentation?
Sorry?
Will you join the courses that were provided in the presentation? The crypto zombies and I forgot, but the one that Vlad also likes.
I took screenshots.
You took what?
I took photos.
Oh, cool.
So I've done that.
Sure.
I remember a question someone says this is really well presented. This is like the exact set of knowledge, I think, in terms of that onboarding someone facility. So good job. I think here, yeah, I don't have any questions, but it's just really great example. Thanks so much for presenting this.
Which example?
This one here.
Great.
Ah, great. So because I heard it's great example. Yeah. Okay.
No, it's a great example. It's really nice and concise. So
Thank
for
you.
beginners, it's wonderful. Thanks.
Maybe you can tell us like more about the casting. Like, are you hiring junior engineers?
Yeah. So we can hire juniors, but like excellent ones. The best one. If you're super smart and you're a junior, probably we will hire you. But currently we have only senior position, right?
Yeah, we mostly hire seniors, but we also hire exceptional juniors. Also, I'm not sure this option is available right now, but one of our smart contract engineers who joined the company actually, he didn't really apply for the job. He first found a bug in one of our smart contracts, and then he received the bounty, and that's how he proved by action that he really is a proficient Solidity developer. So I think that's one of the, if you're looking a job as a Solidity developer, one of the good ways is just to search through all the bug bounties. If you find the bug, then people will respect you and probably hire you.
Can you describe a little bit more about what you guys are working on?
Yeah, so basically we're working for the scaling solution for Ethereum, and actually it's a layer 2 solution. We use zero knowledge proofs, weird words, for describing the project, but the idea was that we create a separate blockchain that relies for the security of Ethereum. So if you do something on zkSync, the security assumption will be the same as on Ethereum, but transaction will be cheaper. And yeah. Stas?
Yeah, I just want that's probably all of it. I just wanted to dig a bit deeper how this layer 2 solutions scale actually Ethereum. Ethereum is permissionless. Well, we don't have to trust a third party, but what does it mean? We don't have to trust anybody. There still needs to be someone who execute this code. There still needs to be someone who check that it's correct. And the point is that we trust the fact that there are a lot of different nodes. They're centralized. They're located all around the world, and it's practically impossible to make them convert against you in particular. And also, if you have your own local Ethereum node, your node will never accept the invalid history. Why? Like I said, that when you develop Solidity, a optimizations are very important because the count is on dollars and not cents. It's because if every small machine has to like execute this Ethereum transaction, it's not scalable. There is a limit on it. And one of the possible things to do this is to like reduce the number of nodes. Say that, okay guys, we have like some super huge powerful servers, similar like Google does, that we will be able to process a lot more transactions, but then we'll lose decentralization, and then we'll lose the fact that like the transactions are actually verified by everyone. We have to actually trust this one big guy like Google that all the calculations are done correctly. And what we're doing at zkSync is we kind of like this big guy, but we using some magic cryptography, we create a proof that all this computation was done indeed correctly. And then all the Ethereum nodes, they will verify this proof. So yeah, we will do the computation. This way we scale, but all the nodes on Ethereum, they check the computation was correct. So that's how we scale, but while not compromising the security of Ethereum.
Do you guys specifically work on it, or are you just not?
Specifically, Vlad is a smart contract engineer, and I also work with Solidity, but I'm kind of like I'm partially working on the protocol, partially in Solidity and Rust as well.
And can you explain how zkSync is connected to a smart contract? Because this is typical Ethereum smart contract.
Yeah.
But I think you will have your own contract probably.
Yeah, so first of all, we use Solidity for building contracts for Ethereum because our protocol, zkSync, relies on this contract on Ethereum. So basically, we have our own contract. And also for the platform itself, we provide a blockchain that can be used with Solidity. So you can write your contract on Solidity and deploy it to Ethereum or to the zkSync. Or you even can copy paste contract and it will work the same as on Ethereum.
Sure.
Yeah, it's my understanding that there's kind of two competing types of rollups right now, right? Kind of like zk rollups and then optimistic rollups. I was wondering, why did you guys choose to focus mostly on zk rollups, and what do you see as some of the advantages of your solution?
I would say that the biggest advantage to zk rollup is fast finality, firstly, because what is meant by finality? Just so that everybody knows. On Ethereum, for instance, let's say that you submit a transaction and you will receive a confirmation that this transaction was included in the blockchain. You cannot just blindly trust that it will be included there forever. So at least right after a few seconds, there might appear some new blocks that will not contain your transaction. So typically, if you deposit on an exchange, you'll need to wait 5 or 10 minutes after the transaction was confirmed by the blockchain. After 5 or 10 minutes, the blockchain, the exchange is sure that okay, this transaction will forever be in the blockchain, and we can safely accept the deposit. And the same and for L2 solutions like zk rollups and optimistic rollups, finality time is at which point do we consider that all the computation that was done on layer 2 is correct. So in case of zk rollups, we write it to the computation, we create a proof, a cryptographic proof, we send it to our contract on L1. Once it's verified, it's done. The computation is considered correct. Optimistic rollups, they they just say, oh guys, our computation was correct, and you have 1 week to challenge us. If they don't challenge them within 1 week or 10 days, then the computation is considered correct. There are some so practically it means that finality time for optimistic rollups is 1 week. There are some stuff which can help exchanges, for instance, to accept deposits faster than 1 week on optimistic rollups. There are still some projects which want to remain fully trustless, like for instance Tornado Cash, and they. Do you know what Tornado Cash is? Okay, so for everyone, it's just a protocol. You can privately deposit their money, and now they also want you to earn interest on that money. And for this earning interest part, they need some blockchain which it has fast finality, trustless finality, which they can verify on chain. With zk rollups, the finality is small, but with optimistic rollups, it's 1 week and they will not work with them. Yes?
If you think about coding on MS, do you see this as a big direction? Because
Well, I don't know. I don't see, this on mainnet, right? If we should see it on mainnet or even on testnet to see how it's competing with zkSync. By the way, you can check out zkSync on the testnet now. It's for the version with general purpose computation with smart contracts on Solidity, and also you can use zkSync for the payments already on mainnet.
Sorry, could you please louder?
Yes, sorry, but can you do all the computations on the VM using zero knowledge proofs, or you are limited in the computations?
Well, yes, we can. There are some, like exceptions for what we support, but these are not. These aren't like stuff which is limited by zero knowledge proofs. Most of that is limited by design, and also they were removed as an optimization. But practically everything is provable. We are bound by some amount of computation which can be proven in advance. But it's fine, because on Ethereum there is a block limit, so like no more than 15 million gas of computation can be used, and the same will be on us. It will be just some other limit on the amount of computation that can be done on zkSync.
All right, so like the thing of rollups is that you compute several transactions, and only once you've reached a certain amount of transactions, you confirm them on the Ethereum chain, right?
Yes, there is two different approach. So we just have a bunch of transactions, we collect them, and then we push the proof on layer 1. So it's a smart contract for Ethereum. But the caveat is how we really prove that transaction execute correctly. First approach is optimistically, we just put the transaction and say, okay, it should be executed correctly. If not, you can prove that. But with zero knowledge proofs, we can use some small cryptographic proofs and push it into the layer 1. So it's actually similar. So we just collect transaction, push proof, and then it's.
But then you have an interaction with the layer 1 chain after every transaction that you have to prove, right?
Not after every transaction, but after block of transaction.
After block.
Yeah.
Okay. So this means that the high amount of transactions that would have otherwise been processed on the Ethereum chain are processed on the zkSync chain. And after the block is filled, we prove this block on the Ethereum chain, and we have just one transaction instead of 50,000.
Yeah, so actually in zero knowledge proof, there is a very good property that you can prove one zero knowledge proof in another one. I don't really want to go deeply into it, but it means that you can collect like a bunch of blocks even, and then create a zero knowledge proof for it. Or then you can collect these zero knowledge proofs and make proof for this zero knowledge proof. And then only one zero knowledge proof can be pushed into layer 1. So there is no limitation exactly that we should push one proof for one block. We can push one proof for unlimited amount of blocks.
This information would then be described in the smart contract for this specific kind of transactions. Well, who would decide how many transactions you would want to bundle until you get your proof from layer 1?
Actually, it will decide the sequencer of the network. Similar as to Ethereum, there's miners, but in our case, it will be sequencers that decide order of the transaction, create proofs, and send it to Ethereum.
Yeah.
To the point about fruiting like more complex transactions, is there a fee associated with having a transaction go through your process? And if it is a more complex transaction, but a simple one might be like sending, right? A more complex one might be interacting with a lot of different smart contracts, if there's more data there. Is the fee, if there is a fee, is it higher for a more complex transaction?
Well, the fee does not depend on complexity of transactions. It depends on the number of computations. So like every step, every like opcode which is executed by your program, it costs some amount of gas. Like on any blockchain, that's how it works. Yeah, and it's just the more these opcodes execute, the more gas you use, the more expensive the transaction will be. You can have complex transactions that interact with a lot of smart contracts, but it may be cheaper than a transaction like in a single contract do a for loop until 1 million. You know?
Sure, I don't have to pay some sort of fee for someone to then, for example, have my transaction included in your like batch, and then someone's going and verifying this, right? Like you're kind of verifying that this all looks up, and that's just free for me. It's not an additional. I'm not saving compared to normal Ethereum, but do I have to pay for that service to save on gas, or is there just no cost associated with that service?
From user perspective, it will be the same as Ethereum. You just specify the number of gas you're willing to pay, the price for each item of gas, and you send it to zkSync. And then it's the same as Ethereum. The opcode price might be different, and it will be different, but the mechanism is totally the same.
Sweet, thanks.
Can you tell us something how you stepped into zkSync and how did you become interested in Web3 at all? And why are you contributing, let's say, a day and working on this?
Well, to be honest, I just was looking for a job, and it was like only one job from which I could get offer. But I was a student. It was the first course of the university.
Yeah, the same is for me. It's like there was a friend of mine. There was a friend of mine who worked at Matter Labs. Like, and he is also a friend of Vlad. He referenced both of us, and also a friend of ours who is currently he's not here, but he's in the company. Yeah, and it was just like, do you want the job? And I was like, okay. And I went on an interview. I passed it. I went through internship, and then like.
You're making it sound too easy to get into the
Not anymore, right?
It was 2 years ago, right?
Yeah.
Yes.
Is the rollups node also decentralized so other users can run a node as to participate in your rollup, or you have the centralized node that just sequence every transaction?
Yeah, I would say that there is no technical difficulties to create it decentralized, right? But actually, it's not a critical path now. So the first goal is to create permissionless zk rollup and make it without bugs and to be sure that it works correctly and it's cheap, right? But then we have a mission to create it decentralized because governance can ban you, or governance can take your server and say you now can't operate with this rollup. Yeah. And yes.
I'm quite interested in the zk part. So you're using snarks to do all this. You publish the proof to Ethereum, right? But snarks, the proof's quite different than stars. Why did you go for snarks versus stars?
We have Plonk, so it's a kind of modified version of Snark. But it's similar. Stark, as far as I understand, it has more data associated with it, and that's why it's more expensive. What's more, the size of Stark actually grows with the number of transactions that it proves. Maybe it's some possible with recursive Starks. I don't know that. I'm not a cryptographer, but yeah, in any way, Starks are typically more expensive than Plonk, than Snarks. And that was I think that was the main reason why we had it. We're not cryptographers, so we cannot like tell for sure what was the first move when we decided to do it. Yeah.
I think for the recursion stocks are not that good because they have much boost on the
Yeah, I switched it over to them. Stars is more than stars.
no question.
Yeah, I think if there are no questions, we can go grab some drinks. Next one, right?
So I can tell you about
Yes.
now first.
Finish up.
Thank you. Very nice. Well, thank you very much for this presentation. I think this was an awesome way to kick our first event here in Berlin. I'm Zaina, I'm with Lift 99. We're here from Kiev. Lift 99 is a tech community of startups from Estonia and from Ukraine as well. We have a lot of Web3 startups in our community, and right now we're building it up, and we're starting a DAO that will connect Web3 communities from all over Europe. And yes, so our aim is to build an investment DAO that will bring more users into Web3. We will be also an educational platform, and you can follow up all of our interest here on Discord and on Twitter. We will be in Berlin for 2 months, hosting a lot of events, so you are welcome to follow, and maybe hopefully we'll see you in more events.
Thank you.
That the drinking commence.
Yeah, the drinking event.
Thank you. Thank you very much, by the way. That was very interesting. Very hard to follow.
Yeah.
So,